A bag contains 6 blue balls and 8 red balls. What is the smallest number of red balls that can be added such that the ratio of blue to red balls can be written in the form 1 to n? So, we have 6 blue balls and 8 red balls. Okay. And we need the ratio to be written 1 to n. Now, at the moment, we have 6 to 8. This is called a unitary ratio, because unitary means 1. So 1 unit, that's where it comes from. So basically what it's asking us to do is to divide through by whatever number this is to end up at 1, because 6 divided by 6 equals 1. Whatever we do to this side, to keep them in the same ratio that they were before, we need to divide this side by 6 as well. The only problem is, if we divide this by 6, that's fine, because we'll end up with 6 separate parts of 1. But if we divide this by 6, then these two here are going to have to be split into 2/3, and you can't have 2/3 of a ball. So at the moment, we would end up with 1 to 1 and 2/3, which doesn't make sense. So to be able to divide by 6, the number of red balls we have has to end up being, has to be a multiple of 6, because if you divide a number by 6, if it's not in the 6 times table, you'll always end up with a fractional answer. So, we need the smallest amount of red balls that we can add. What we need to do is find the next number. So, if we had 6 to 6, that would simplify to 1 to 1, which is fine, but we've got 8, so that's too few red balls. So next we could try 6 to 12. If you divide both of them by 6, you end up with 1 to 2. And that works, that's perfect, because we've got 8 balls, 8 red balls, and we've just shown if we had 12 red balls, we would end up with a whole answer. So what we need to do to go from 8 to 12 balls is to add 4. So 4 extra red balls will allow us to write our final answer in the form 1 to n. In this case, we've ended up with 1 to 2, without there being a fractional answer.